Thank you. And thank you to Paul for inviting me to this symposium. And initially, actually, my title was quite different. I wanted to present only the constraint about the ERW applications in agricultural soil, but he gently persuaded me to talk about the current project that we are doing funded through the Port Innovation. So I'm going to give you a brief overview. The project has just commenced, so don't have much experimental results to share, but I'll give you some background, and my focus will be more on looking at the constraint in the ERV technology. I think this morning we have a broad range of talking about the general CDR technologies, and Paul gave a very comprehensive introduction about the ERW. I'll be poking few holes in the ERW, not in any negative way, but try to kind of understand that obviously there are some good points and there is a great potential of this technology, but we need some considerations about some variables that when we looked at the modeling which was presented by the University of Sheffield colleague, I'm always apprehensive about some of these, large models with millions of assumptions, underlying assumptions, which most of the time we don't understand and don't know. And I have seen this more recently in the biochar. I worked in that space for over 10 years, part of 2 national projects, and I think we had more than necessary enthusiasm for the biochar technology in Australia. We were the first one to, I guess, become an international player in that. And over the year, we have seen the reality is quite different to the facts, what happened under field conditions. So anyway, that's the sort of background. Paul asked this question, that how long we have been working in this. I started working in this space in 2014. We did an experiment looking at pure olivine, 2 different particle size, less than 70 micron and greater than 70 micron. Did few continuous cropping of the grass, and as you can see that there is some potential in these 2 particle sizes and 2 soils where you can see the soluble magnesium was increased with the applications, and increase, as you would expect, was greater with the finer particle size. Soil pH was increased, so there was some liming effect. And plant biomass was up and down, so that we didn't have a sort of consistent response as you'd expect. This work possibly will be written one day, but it kind of, with the many things going on, sometime things don't happen with the time. So our new project, which we have started, the project actually started last year, but the real thing have started actually in January this year, generously funded by Port Innovation. There is another industrial partner, EGSEC in here, which is also making some contribution in terms of supply of the rock powder, and the University of Sydney is making a significant contribution in terms of a PhD students funding as well. We are trying to cover quite a few things here. I'm not going to go in details, but like Paul, we are also looking at the actual determining the potential of the ERW in some field trials. We'll do both, or we'll do laboratory incubations, glasshouse and field experiments. And we will, I'll focus more importantly, and I think this is more important in terms of the adaptability of this technique by the farmers or growers. What are the additional effects on, in terms of the plant productivity or quality of the cropping, etc.? Because at the end of the day, I think if there are obvious benefits from the applications, that's where the uptake is going to happen from the farmer's perspective. And we will try to see what sort of variability you get from different rock powders in different soils and some laboratory mimicked conditions such as temperature, moisture, etc. And we have a PhD student who will be guided by a colleague in physics who will be looking at the comprehensive environmental sustainability of this technology and perhaps comparing with some of the other CDR technologies using all the variables possible. We are about to commence our field experiment for this project. We have acquired the rock dust, and I think this was a question asked by somebody else. I should make it clear, this is not a purpose produced rock powder. This is a byproduct, this is a waste product. So this should be understood, and this is important, that we are not blasting the rock somewhere and then grinding it and then trying to apply to farmers' sites. This is a waste product which companies who produce these concretes for building roads and constructions, this is a washing product, or they basically remove the fine powder, and we are trying to use this powder. We already have 2 identified field sites in Victoria, where these are the commercial vegetable farms, and we have 1 possible citrus orchard in New South Wales, and we have more interest in 1 or 2 probably stone fruit crops as well in New South Wales. So that's what our targeted sort of applications are likely to be. I should point out here that our system is quite different to GRDC kind of projects and other things. We are looking at, first of all, some of the products which are known to accumulate trace elements, particularly leafy vegetables. And one thing which has not been pointed out, basalt contains reasonable concentration of some trace elements, which are potentially toxic to human, okay? So elements such as nickel, chromium are present. And if we continuously apply high doses of these materials, and if they dissolve or weather, then those elements are likely to release, and they are likely to accumulate in the topsoil, and they might transfer into some of the edible parts of the crops. And as I said, particularly it's important for the leafy vegetables because they are known to accumulate high concentration of these trace elements. So it's important that if we really want to apply these under real conditions, we need to look at all aspects. And other thing I should point out, our field experiments are not going to be as large that we have got trial going for 1 hectare, 2 hectare. Because we don't know, there are lots of unknowns here. We cannot contaminate farmers' sites if there are some potential. Only 3 minutes left. So we will be having trials with a fairly small plot sizes. I should run. This graph is just to show you the large variability what you gather. From the literature we have, and I should also introduce Zhongchang Yang, who is a postdoctoral fellow in the project. He has done this work. there are many different kinds of material used. Largely, most of the experiment, about 60%, use rock for applying. And in here, you can see there are different kinds of rock. Majority, obviously, is basalt. And then there are many different types of minerals which are present in rocks. And also, the chemistry or the chemical composition of the rocks will also vary. More importantly, when mineral dissolves, they dissolve at a very different rate. And there are 3 to 4 order of magnitude differences in the weathering rate of minerals. So you can see that you can't assume 1 or 2 dissolution rates and make a model. There are huge differences here. This is something which I did a few years ago. And obviously there is effect of the soil pH as well. But you can see 10 to minus 9 coming down to 10 to minus 13, 10 to minus 17. So there are 7, 8 magnitude order of difference in the dissolution rate of various minerals which are present in different types of rocks. In a more simplified manner, you can see here in this slide that for a hypothetical 1 millimeter diameter particle, it can take a few million years, such as in quartz or micas, muscovite, whereas some of the simple ferromagnesium minerals could dissolve in a few thousand years. So there are huge differences in dissolution rates. I'll hurry up. We measure many different phases in looking at the weathering of these rock minerals. People look at the solid phase, solution phase, gas phase, and plant phase. And depending on what phase you are looking, what you are analyzing, you will get different answers. Okay? I don't have time to go into that, but there are so many variables depending on what you are measuring and what else can affect in the real soil system. So I think there are more modeled papers than the real work in this work, which is unfortunate. I really feel sorry that people are getting into modeling and there is a handful of real studies done. If you look at the CDR rates here, you can see it obviously depends on the application rate, but there is no consistency. It's not that application rate increases, CDR increases, or there is no effect of the application rate, and there is no effect of the application rock type consistent with any of the studies. I think I'm run out of time, but this sums up lots of variables which possibly can affect what we are measuring and what CDR number we are likely to get. I should thank my funders. Hopefully in a year or two, Zhongtang will have more results to present. So thank you, Hort Innovation, Sydney, and EXEC. And thank you, Paul, for the invite.
Thank you. Thank you.